Okay, good evening. Today I'm not going to teach. I'm going just to do question and answer or revision that your uh, that your need or any questions that you have. But before I go, Tyler, what's your question, Tyler?
Okay, so specifically, I have a question about question 1 from our week 3 homework.
Question 1, week 3. Go on.
Yeah,
Let
bit
me.
embarrassing because I think it's meant to just be when they're doing the moment calculations.
It's okay. Don't worry about it. Nothing's embarrassing over here. Week what?
3.
Question number?
1.
Oh, okay.
And
So
I'm just curious about how they've calculated their moment values about z and y in this question specifically.
okay.
I'm not sure if there's something I'm not understanding about point loads or not, but
Okay. Not to worry. Let me string this down. I also have not a clue how they calculate your moment, but let's see. So you can see this structure, okay? And I think the thing you're confused about is like how they know this is the M, am I right?
yes, and where they do their mz is equal to,
Yeah,
and then
yeah, no problem. Okay, so questions like this is always a bit abstract, 3D problem, 2D world, because you write on paper is 2D. So we will just draw. Okay, so this will be our X. All right, we draw a transformation. This is our X. Whenever you approach this a problem like this, it's important that you draw your transformation. Okay, Y. And then this is our Z. This is the first thing we have to get sorted out first. Why? Because the formula states that stress X is equal to my or P over A. For this case is so before we go any further, this is a case where you have eccentric, unsymmetrical, bending. So the eccentric part comes where you have px over a, okay, and then you have plus my over iyy multiplied by z minus by mz over izz multiplied by y. Okay. So the eccentric is caused by the px over a. Okay. Without the px over a, it's known as eccentric. Okay. So Tyler's question is how they acquire the moment. Okay. So we know that moment is applied on two axes. Okay. If we look at the front view. Okay. So I'm going to sketch the front view now. Okay. I'm going to Tyler or anyone, anytime if you have a question, just stop me. Okay, and ask again. Okay. Don't just guess. Okay. Today is the time that you ask question.
Roger.
Okay. So this is your Y. And this is your Z. Okay. And then we are going to, so it's 1, 2, 5, and 75. So I'm drawing the front view now. I'm drawing the front view now. Okay. And then I'm going to draw over here by observation. You know where the centroid is just by pure observation. Okay. So I'm going to draw our centroid. You no need to go to the calculation because it's symmetry. Okay. So this is one axis. And then this is the other axis. Then I'm going to do the dots I'm going to put the forces down. Okay. So this is our dot. It's coming towards us. This is going at 14 kilonewton. This is coming towards us at 25. Is it 25 or 28?
28.
Both 28. 28 kilonewtons. So we know that moment, right? Just to quickly recap. We know that moment all of a sudden I can spell. Is equal to force multiplied by perpendicular distance. So the first thing we're going to do is we're going to do our ZZ axis first. Okay, so this is our ZZ. So moment about ZZ axis. Okay, so if you use right hand rule, I'm going to assume this to be my moment about Z. Okay, that is just an assumed direction. Okay, you want to assume it opposite later on when you do your calculation. If it's negative, you just flip it in the other direction. Okay, so that is our MZ. Okay, so I'm going to have anti-clockwise as positive summation about moment about the z-axis is equal to. Now this is not static analysis. I'm doing the summation about moment about the z-axis. Okay, so we know the distance, right? So we know the distance. So we are also given the distance from here to here. We are given the distance, and this is equal to 125 divided by 2, which is 62.5. Okay, we are aware that this is 62.5. And then the other one, because of it being symmetry, right? This distance is also equal to 62.5. So with this, right, we look at the 28. The both 28 is going to generate a anti-clockwise direction, right? So 2 multiplied by 28 times 10 to the power 3 multiplied by, so it's in millimeters, 62.5, I change into meters. Okay. Then the 14 is going to, if you look at the 14, it's going to generate a different direction moment, right? It's going to go against the positive, so it will be negative 14 times 10 to the power 3. And then again 62.5 times 10 to the power minus 3. So moment about Z will be equal to 2 times by 28 power 3 times by 62.5 power minus 3 minus by 14 power 3 times by 62.5 power minus 3. So the moment is 2625 Newton meter. And this direction is valid. Okay. So this direction that we've drawn is valid. So what does it mean? It means that MZ at the top, head of the compression vector is compression, bottom is tensile. That we figure out already. Okay. Tyler, is it okay?
Yep, this makes sense.
Makes sense. Then I'm going to do YY. Okay. So we're going to do YY. Okay. So YY, I'm going to assume, let's say for this time, I'm going to assume this as positive. Okay. So we are again aware that we are given the perpendicular distance from here to here. We know this distance. And also we know this distance. And these are equal to 75 divided by 2, 37.5 millimeters. So for this case, we assume that positive is going in this direction, right? Some mention about moment in the y direction. So this will be equal to the 28 over here. It's going to be positive. So it's equal to 28 times 10 to the power 3 multiplied by 37.5 times 10 to the power minus 3. And then you will have 14 minus 14 times 10 to the power 3 plus by 28 times 10 to the power 3. So I'm taking these two now, the 14 and 23, and then multiply by 37.5 times 10. Oh, I'm squeezing. Pardon me. I'll move it so it's clearer for everyone to see. Times 10 to the power minus 3 again. Okay. So this work out to be 28 minus 14 power 3 times 37.5 power minus 3 is equal to minus 525. Now, minus 525 over here, what does this mean? Means this direction that we have drawn is wrong. Okay, so this direction is wrong. So all we need to do is to flip it around. Okay, flip it around. So you put this is equal to 525 Newton meter, and then you flip it around. Okay, so this means that moment about y, right? This will be under compression, and below will be under tensile. Okay, or the tail end of the moment vector will be under tensile. Tyler, does that make sense to you now?
Yep, it did. And the reason I was just a bit confused was just by, if you look at the my calculation in the solution,
Yeah.
they didn't have. I think now it's just a typo, because like the number that you calculated ended up being the same, but they have negative 37.5 times 14, and then plus the other two numbers.
Oh, you mean so they have 14? I see what you mean. Yeah. Solution manuals fault. Okay. Now this makes sense, right?
Yeah, I was trying so hard to figure out how the
No.
14 could be negative in both the y and the z, and the 28s were positive in both ways, and it was very confusing.
Yeah. There is. Yeah. Welcome to the solution. Yeah, I think they have a typo there. Okay. So yeah, okay with this, right?
Very much so. Yes, thank you.
Okay, you're more than welcome. Next question, please. Anyone? Anyone have issue with homework? So quiet. It's scary, you know, when it's quiet. Only for Taylor. Anyone else? Okay, if no one have question, I like to do but elaborate on some points of the course where, as I said, I've been teaching this course for about 8 times already. What students are most confused of, okay? So I'm going to look into, at any time anyone have a question, you can just stop me, okay? And I'm going to do this example, not example, just a good revision. So one of the topics students are confused are centric, symmetrical, unsymmetrical. Bending. Okay. So we know that the formula that we are using, because it's centric, is stress X is equal to my over Iyy z minus by mz over Izz.